Greetings, everyone. Today we are going to go over the Algebra 1 Spring Final Review. Now, you may have been given this worksheet in class. It may be posted on Google Classroom. It might have been provided to you in some way. And our goal of this video is to just review the content and the questions, make sure you have a solid understanding, and make sure you visit with your teacher if you have any specific questions. All right, let's look at the first set of problems. These first questions ask you to solve the system of equations, specifically using the substitution method. For substitution, you need to isolate a variable first. So in number 1, I'm going to get the x by itself because then all I need to do is subtract y. So I'm going to have a negative 6 minus y. Now, with this equation, I can substitute this entire expression into x in the other equation. Make sure you don't plug it back into itself. Otherwise, you're not going to end up with the solution you need. So I'm going to do 2 parentheses minus 3y equals negative 2. See how it looks like the first one? And then I'm going to take this box, this expression, and I'm going to fill it in for the variable x. From there, it's just solving your equations using PEMDAS backwards. So my first goal is I'm going to distribute that 2. I'm going to combine like terms. I'm going to kick that 12 to the other side by adding it over. And I'm going to divide both sides by negative 5. Now remember, if you need more instruction than this, you need to go back and see your instructional videos. This is intended to be a pretty quick review. Now remember, we're looking to solve for x and y. I've only found y, so that means I need to take this y value and I need to plug it into either equation at this point. Once you know one value, either equation works. So I'm going to choose the second equation because it's smaller. And wherever there's a y, I'm going to plug in a negative 2. And all I need to do to solve that is just add that 2 over, right? And I've got x equals negative 4. Now I have to write my answer in a very specific way. It's a point value. So negative 4, comma, negative 2. If I take a look at example 2, let's see. First thing I need to do is isolate a variable. I'm going to get x by itself again on the second equation because it seems like the easiest thing to do. You don't have to. You have other options. And now I'm going to plug this expression in for x in the other equation. So let me write that out. I'm going to have 4 parentheses minus y equals 4. And in parentheses, I'm going to write out that 10 minus 2y. So first thing I'm going to do is distribute. I'm going to combine like terms. I'm going to kick the 40 to the other side by subtracting it. It's currently a positive 40, so I'm going to subtract it. And then I'm going to divide both sides by negative 9. Negative divided by negative, positive. Now, to find my x value, I'm going to plug that in for the y value on either equation. So this time I'm going to use the first equation. So 4x minus, instead of y, I'm replacing it with a 4 equals 4. I'm going to add 4 to the other side. I'm going to divide by 4. And for my answer, I get a clear 2, 4. All right, on this next set, notice the directions look similar, but we have the word elimination. In order to eliminate, you need a set of coefficients that have the same value and opposite signs. So if I look at number 3, I'm looking at those y values. If I take the second equation and multiply it by negative 4, let's see what happens. I would have negative 8x minus 4y equals negative 32. Well, if I bring down that first equation, notice anything? I made it so that if I do old school addition, the y's will cancel. So negative 8 plus 3, negative 5x, drop my equals, and negative 35. If I divide both sides by negative 5 to isolate the x, I arrive at a 7. Now, similar to before, it turns into a substitution problem. I need to plug that 7 in somewhere and solve. I'm going to plug it into the second one just because I see it looks a little simpler. Oops, so instead of x, I'm putting a 7. All right, 2 times 7 is 14. I'm going to minus that 14 to the other side, and I'm going to arrive at negative 6. So I need to write my answer very specifically, x, comma, y. All right, let's take a look at the elimination method for the second set. Looks like if I times by 2, it's already opposite signs, but I could get rid of the x's, so let me try that. It would give me a negative 8x, negative 14y, and negative 4. Oh goodness. Watch this. If I bring that first equation down just so I can line them up and see, look at what happens. This is a unique situation. If I line them up and do my old school addition, I end up with 0 plus 0 equals 0. Now, even though everything cancels, the numbers matter. Does 0 equal 0? Yes, that is a true statement. So I need to write that I have infinitely many solutions. If it was an untrue equation, like 5 equals 0, that would be my no solution. All right, let's take a look at this one. First, we want to identify what are the variables we're trying to find. We want to create the equations and then solve the equations using the method of our choice. So we're talking about buying donuts. Alex bought 8 glazed and 4 frosted, and he spent a total of $11.32. But they needed to buy more, so Casey went back and she bought 6 glazed plus 2 frosted, and she spent $7.44. And we want to find out what did each donut cost. So I'm noticing that the F's are the closest. If I multiply the second equation by a negative 2, I'm going to have something I can work with. So I'm going to rewrite this. And again, you could use X's and Y's. I'm going to keep it with the variables so I know what I'm talking about. I've got a negative 12G glazed minus 4F for frosted equals, what do we got, 1488. Oops, negative. All right, 8G minus 12G is negative 4G. Cross off the F's. Equals, this is going to be a negative value as well. I need to get my calculator out here. All right, we have 1132. We're subtracting 1488. I got negative 356. I'm going to divide both sides by negative 4. And I arrived at 0.89, which seems like a silly number, but it makes sense because we're talking money here. So this means glazed donuts, I'm going to start my answer, are 89 cents. Remember, it's $0.89 or no point and just 89 cents. One way or the other. Careful with that decimal. I still need to find the cost of the frosted donuts. So let's go back to the beginning. I'm actually going to rewrite this equation, but instead of G, I'm going to put 0.89 plus 2F equals 744. All right, definitely need my calculator here. 6 times 0.89 is 534 plus 2F equals 744. I'm going to take that 744 and I'm going to minus the 534, which gets me to 2.1. And if I divide by 2, I've got F equals $1.05. So frosted, make sure you use the full word, costs $1.05. So we created a set of equations. We solved the system by the method of our choice, and we have correctly labeled our answers, and they make sense, right? If you get negatives, not good. If you get $50, not good. So make sure your answer makes sense. Another way to solve a system is by graphing, and we're specifically going to solve this one by graphing inequalities. So the first thing I need to do is I need to isolate y on this first inequality. So I'm going to rewrite it over here. I'm going to minus that 3x over to the other side. I'm just isolating the y because I want to put it in slope-intercept form. I'm going to divide everything by -5. Oop, I divided by a negative. So remember what that means, got to flip that sign. I get a -5 and a positive 3/5 x. So if I go to graph, I'm going to start at -5. That's my y-intercept, my b-value, and I'm going to count my slope. Rise 3, run 5. Rise 3, run 5. Let's go the other direction. Down 3, left 5, and I run out of room. Now because it's or equals 2, we're going to have a solid line. My equation says y is less than, so I'm going to shade less than the line. Or if you plug in 0, 0 into the original, 0 minus 0 is not greater than 25. So 0, 0 is a bad point. So we shade away from it. The second equation says x is greater than -3. That means we're going to slice the x-axis at -3 with a dashed line. So this is a vertical slope. It says greater than, 0 is greater than -3. So we're going to shade to the right. Now, what we talked about in class is we care about the double shaded area. So I really want to shade in this sort of bottom right area, contained area. That's the area and beyond that will be a true solution in my system of inequalities. Exponential functions. All right, let's take a look. Remember all those exponent rules from our foldable? The first rule is that anything to the 0 power is 1. Also, negative exponents, not negative numbers, get kicked to the other side of the fraction bar. Another rule is that when dividing like bases, you subtract their exponents. 4 minus 1 is 3. Another rule is that negative exponents get flipped to the other side of the fraction bar. So b to the third goes to the bottom, b to the second is now on top. Now I have a division problem. I can divide these like bases. You'll notice that the larger exponent's on the bottom, so 3 minus 2 is 1, and we still have a to the third on top. Another rule is power to a power, which says we distribute the exponent to all other exponents by multiplying. So x -2 times -2 is positive 4. Y -4 times -2 is 8. And x 3 times -2 is -6. Oh, we've got another rule here. We've got to remember we have multiplying like bases. When we multiply like bases, we keep the base and add the exponents. So I now have x to the -2. Let's go back to that negative rule which says negative exponents get kicked to the other side of the fraction bar, and my positive exponent stays. Alrighty, let's combine these rules. The first thing I see is a set of parentheses. There are two pieces of information here. There's the 2 and the y. So I'm going to leave the top alone. The 2 gets a -2 and the y gets a -2. Now we know the rule about negative exponents. They get moved. Treat each piece on its own. That 3 is on its own. It stays. This x to the -3rd, kick to the bottom. It becomes a positive. This 2 to the -2 gets kicked to the top. And this y to the -2 gets kicked to the top. Now let's simplify. If I take a look at these numbers, 2 squared is 4. When numbers are next to each other, it's multiplying, so I have a 12. The y squared is nice, clean, positive by itself, and x cubed is on bottom. Now keep in mind there are sort of other approaches. You can choose which rule you'd like to take care of first on some of these, but in the end our answers should still be the same. On number 11 I see a multiplication problem. All of these are being multiplied. X times x, When we multiply like exponents, we add their bases, because remember, if I have 3 x's and I have 4 x's, I have 7 x's. If I take the y values, y to the 10th, y to the negative 8th, add their exponents, I get y squared. So see, I got to avoid the negative there. Number 12. First, every piece gets a 2 because everything is in parentheses. Power to a power says we multiply, so u to the 4th, v to the negative 4th, v to the 6th. Next, I'm going to kick that negative to the other side. So that v is going to fall down to the bottom with the v to the 6th. I've got 2 v's. When we multiply like bases, we add the exponents. All right, the most recent unit that you'll be most familiar with is our polynomials. So let's start off with the basic operations. We're going to start off by adding. So when adding polynomials, you want to add like terms, and I also like to write it in standard form right away. So the first thing I notice is I have a negative 8x cubed and a positive 9x cubed. If I combine those, I have 1x cubed. I then go down to the second exponent. I have a positive 7x squared and a positive 2x squared. That's going to be a positive 9x squared. See how we keep the term the same? And then I see that I have a positive 4 as a constant and a positive 7 as a constant. So I'm going to have a positive 11. Now I like to make the marks underneath just so I don't forget about anything. I'm kind of like crossing things out as I use them almost. Subtracting. Now my suggestion for subtracting is to distribute the negative and turn it into an adding problem, which means the first parenthesis always stays the same and the second parenthesis changes all its signs. Okay, maybe put a star by this one. I feel like this was the one that students struggled with the most. Change all the signs in the second one and then let's start combining like terms. I have a 1x squared plus a 3x squared. That's a 4x squared. I see a positive 6x and a negative 2x. That's a positive 4x. And then lastly, I see I have a constant of negative 8 and positive 9 for a positive 1. See how that's different now that I changed those signs? So watch out for subtracting. All right, let's try one more subtracting problem because it's just a tough operation. Again, the best bet is to distribute that negative, which makes a negative 3a squared, positive 4a, and a positive 5. And then I drop down all that information out front. Now let's combine like terms. I see a negative 5a squared and a negative 3a squared. That's a negative 8a squared. See how I keep that a squared? Next, I see a positive 6a and a positive 4a for a positive 10a. And then lastly, I see a constant of plus 2 plus 5 for plus 7. I like to put C's underneath or use sideways C's for constant. So that's why I keep curving that. All right, next, number 16, I have a binomial times a binomial. So I'm going to distribute, call it double distributing, or some of you might be more comfortable with the acronym FOIL. Either way, I should start off by showing 4 terms, meaning x times x is x squared. X times positive 9 is positive 9x. Then I need to distribute the negative 1 for a negative 1x. Negative 1 times 9 is negative 9. Then typically the middle 2 terms should be like terms. So positive 9 minus 1 is a positive 8x. Let's drop down that 8x squared. We'll drop down that minus 9. We have no other like terms. It's in standard form. Let's take a look at a couple more. I'm going to zoom through these ones pretty quick. Again, we're distributing either double distribution or FOIL. Negative 15x. Oops, I forgot my squared on the first one. Careful, that was an x times an x. Last would be a positive 25x and a negative 25. I've got my like terms. Show those steps. Don't skip over those. That shows us that you're working authentically and that you understand where your answer came from. Now, common mistake, 18. Put a star by this one, you guys. So often students distribute that squared, but we can't because there's two terms. This is a binomial. So think about, what does squared mean? Squared means we have something times itself. Now, look, we just made it easier because now it's a multiplying problem again. So let's distribute x squared plus 3x plus 3x plus 9. Combine those like terms, and we now have our final expression in standard form. Everyone's favorite, let's do some factoring. Okay, first things first, always check for a GCF. We can't stress this enough. We keep forgetting about it. So first thing I notice, darn, I can't take anything out of that number 19. So I notice it has 4 terms. 4 terms means grouping. All right, my first GCF, I can divide out of the first set. I can take out a 3x squared, which leaves me with an x and a minus 9. Oops, excuse me, minus 3. I'm already predicting my answer here because on the next set, the only thing I can divide out is a 1. But notice, I want my parentheses to be an x minus 3. This is my goal, you guys. I want the same thing. So I need to divide out a negative 1 to obtain that parenthesis. Now that I have the same thing twice, I'm going to factor that same thing out twice. If I factor it out, my leftovers are a 3x squared minus 1. Now be careful. Sometimes you can keep factoring. This particular problem you can't. But if it would have said x squared minus 1, you could have kept going. Let's take a look at this next one. The first thing I noticed, GCF, yes. Let's take out a 7x. Now, do not get rid of that 7x. It exists. It matters. It's still out front. 7x divided by 7x is 1, plus 28x squared divided by 7x is a 4x. Sometimes factoring only means GCF. That's okay. All right, again, check for GCF first. On 21, I don't have a common factor, so I'm going to break up into try factoring. So first thing I want to see is factors of A are 1 and 1. Perfect. Factors of 70. Oof, 1 and 70. 2 and 35. 3 doesn't fit in. 4 doesn't fit in. 5 will. Let's see, 5 will fit in. What do we got? 14 times. 6 doesn't, 7 does, 10 times, 8 doesn't, 9 doesn't, and then I'm repeating myself, right? So show me those factors. The first terms have to be XX. My signs, I gotta play the sign game. One's positive, one's negative. Now, which of those factors can get me to 3? Not those ones, not these ones, not those ones. I'm left with a 7, 10. Now, if my middle term, if it's a positive 3, I want my bigger number to be positive and my smaller number to be negative. Now, don't stop there. Check your work. If I multiply this out by using my double distribution, I can confirm that I have arrived back to my original expression. So, check your answer. Good. Let's take a look at the next one. GCF first. Oh, nothing I can take out. So I'm going to start listing my factors. 1 and 5, 1 and 8, 2 and 4. Ooh, I'm going to have some guess and check here. Let's see. No matter what, I'm going to have a 1 and a 5, right? Like I'm set there. There's one set of factors. But 8, I'm going to play the game a little bit here, you guys. I'm going to start with 1 and 8. If I multiply that out, an 8 and a 5 will never get me to 3. Cross it off. Let's try again. I'm going to try 8 and 1. Let's flip it around. That would get me a 1 and a 40. Oh my goodness, that's so far off. Let's try this time a 2 and a 4. Now, if you can shorten this process up, that's fine, but show us your work. Oh my goodness, we need your work. We've got a 4 and a 10. Oop, that's promising. Okay, I want the 4 to be negative and the 10 to be positive because I want to get a positive 6. Let's check our work. Multiply 5d squared minus 4d plus 10d minus 8. Combine those, yes, positive 6. I'm happy with my answer. Show some work, you guys. We want to see that you're authentically understanding this work. All right, let's take a look at a couple more, you guys. This factoring is so important going into geometry. You're going to factor, oh my goodness, in algebra 2 or college algebra. Yes, factoring is everywhere. You're going to keep using it. So first thing I notice, GCF. I can take a 2 out. If I divide every piece by 2, I get a 3w squared plus w minus 2. Now, that 2 still exists. Do not get rid of it. But my factors are 1 and 3 and 1 and 2. So that's good. I'm probably going to have less guesses here, right? So no matter what, I've got a 1w and a 3w. If I want to get a 1, then I don't want the 2 to be multiplied by the 3. So if I multiply this out, we got to play the sign game a little bit though here, huh? I want a positive 3 and a negative 2. Here's what I mean. If I multiply, my first and last multiplying are going to be fine. I care about the outer and the inner. And if I combine those two, some of us called it the rainbow. I mean, that's just a silly way to remember it. I get my positive 1. Okay, so that's good. But that 2 needs to be taken out. You won't get full credit unless you simplify the polynomial completely. All right, this next one does not have a GCF, so let's jump straight into some factors of 18. Oh my goodness. 1 and 18, 2 and 9. We got 3 and 6, and then I'm repeating myself, right? Which of those factors will get me to a 7? Nope, nope, yes, a 2 and a 9. If I want it to be a positive 7, I want the bigger number to be positive. Okay, double check if I multiply it out, right? B squared plus 9b minus 2b minus 18, positive 7, perfect. I'm happy with my answer. Let's keep going, couple more. 25 is 4 terms. So let's review that grouping again, okay? I'm going to group the first set and the last set. I can divide out a 3n squared. Remember how it's kind of helpful to write it underneath, right? If I divide out a 3n squared, I got an n plus a 1. That one matters. Now I'm predicting if I want my next parenthesis to be n plus 1, then I need to divide out a negative 1. Be careful of those signs. Those have been forgotten a lot. Now, I have the same thing twice. Good. Let's write it once. I've got an n plus 1. If I divide that out, I'm left with a 3n squared minus 1. Now keep in mind, you might actually be asked to solve these as well. If I set this equal to 0, I would have an answer of negative 1 and an answer of, let's see, the square root of 3 over 3. Oh my goodness. So make sure you're comfortable with solving as well. This next one is special, you guys. Now, you could think of it as a problem with a 0n squared. If that helps you process this and do trifactoring, go for it. But I notice that both terms are perfect squares. That means this is a difference of squares. If you need those notes again, take a look. That means 4n squared square rooted is 2n. 9 square rooted, 3. If it's a difference, it's plus minus. It only works if it's two terms, perfect squares and a subtraction sign. If one of those elements is off, no go. You got to figure something else out. The last topic, most recent, is just breaking down those radicals. Remember, it's helpful to have your perfect roots list written off to the side of your paper. I love it when I see it on students' papers because it makes me know that they're thinking about it. They remember it. They know how to break these down. So 80, 4 fits in yes, but so does 16. 16 fits in 5 times, so that gets me to 4 radical 5. Remember, this is a good root, bad root. Bad roots stay in radical jail. Let's break up this 108. Now, use your calculator. Do a little bit of guess and check here. So I'm starting at 108. 81 doesn't fit into 64. Nope. 49. Nope. 36. Yes. Start with the larger values. 36 fits in 3 times. Now be careful. 4 also fits. But I want to take care of the 36 because it's the larger root. Square root of 36 is not square root of 6. It is just 6. And the bad root stays bad. All right, let's take a look at the next one. We have 50. Anytime you're dealing with sort of that quarter value, you're going to have 25 involved. Square root of 25 is 5, radical 2. Now, don't forget that if you reduce these radicals, the 4 still exists. So 9 and 2 fit in. Square root of 9 is 3. Notice I just dropped these all down. Now, when these are next to each other, that implies multiplication. So I have a 12 radical 2 left over. Now, this was a very quick overview of this semester. If you need more help, make sure you seek out help in the Sabre Center with a teacher. Watch the original instructional videos. Seek out other YouTube videos. A couple other ideas on how to study is to rework homework problems, rework notes examples, and most importantly, before finals, make sure you get a good night's sleep. Do anything you can. Stay hydrated, and you've got this. We'll see you at finals.